Hello friends, welcome to our channel Study Guide. So friends, as we have stated earlier that we will bring the general engineering classes for the RRB CBT 2. Okay, so here we bring the class. This is our class 1, but before we have started the class 1, we want to tell something you. That is a very simple notice. That is this version of the general engineering classes will be available in all the 3 languages, that is Bengali, Hindi and English. Okay, and this is the English one. Okay, so let us start with the general engineering. General engineering is very important to the perspective of all the electrician, electronic mechanic, and also for the automobile and fitter, because in this part you can score many marks. Okay, the more marks than any other section. Okay, and this is common to all of you, for all electronic mechanic, electrician, fitter and automobile. Okay, so let us start these classes. So first, before we start the class, let us understand what is force. Okay, what is force? Force is the external agent by which after applying, the velocity of a body can be changed or cannot be changed. Okay, that means there is a, okay, let us see by the digital pen. Okay, suppose there is a small, okay, suppose there is a small object. Okay, there is a small object in the street. Okay, now if we apply a force, we apply external agent by our hand or by our leg. Okay, it will be displaced. Now if there is a large object, okay, there is a large object, very big object, like a big stone. Okay, now we cannot remove by it. Okay, now we are applying the force, but we cannot change the displacement, change the velocity. Okay, but the force is also acting. So what is the force? Force is the external agent by which, if we apply, the velocity of a body can be changed or cannot be changed. That is the force. Now this concept of force will bring us to the work done, and work, our syllabus, work, power and energy are included there. So let us start the work done. Whenever a force acts on a body, now the force is acting on a body and it undergoes some displacement, and by applying the force we are able to displace the body. Okay, now there is 2 condition. Whenever I say it, what is the in the definition of force, I have talked 2 point, that force, if I apply the force, there may be a displacement or there may not be a displacement. Now if there is a displacement, then only the work is said to be done. If the displacement has done, okay, displacement has work, then the work is said to be done. Okay, now if I apply the force on a small brick or on a small ball, okay, and I throw it to a field, that means I am able to displace the ball or displace the brick. That means the work has already been done. Now what is the work done? Work done is equals to force into displacement. Work done is equals to force into displacement. The definition of work done is force into displacement. Work done equals to force into displacement. Now let us see it by a figure. Okay, now from this point we are applying a force. If we apply a force, and then the object moves this point. Okay, so there is a displacement of the center of the body. Okay, if there is a displacement of the center of the body, okay, this is the S and the force applied is F, so F into S. Okay, what is the work done? Work done equals to F into S. Now inclined plane, okay, inclined plane or force is inclined. Okay, then what will happen? So let us think about the same object. Okay, Now what I am doing, I am applying the force from this point. Okay, so a angle will be created, and this angle will be called as the theta. Now the force has two component. Now this force has two component. This force has two component. This is F. F has two component. One is the sine component and one is the cos component. We are interested about the cos component, and this one is the cos component, and this one is the cos component. Okay, now I am applying the force like this one in the inclined, and this is the angle theta in between the force and the horizontal line. Now I am able to displace the body to this point, and this is the displacement between the center to center, and there is a S. So what is the total work done? What is the total work done? Work done will be force into F. Now F cos theta. Okay, in the first figure there was only F, but now there is the F cos theta. Why the F cos theta? Because now the which component of the force is displacing the body, that is F cos theta. F sin theta is just acting opposite to the F sin theta is just acting opposite to the gravity. Okay, F cos theta is displacing the body to the point A, position A to position B, and the total displacement is S. Total displacement is S. So F cos theta multiplied by S. So W equals to F cos theta multiplied by S. Both of the equation will be required at the time of problem. F equals to S into S and W equals to F cos theta into S. Whenever there is a component concept, we require the F cos theta. Whenever there is no concept of component, then only F into S. Okay, so let us move to our next slide. Here we have discussed some of the unit. Okay, what is the unit of work? Okay, in the SI system, on the SI system, the unit of work is joule. Okay, what is the definition of joule? Joule said that 1 Newton meter. Okay, joule is also equals to 1 Newton meter. Okay, so when a force of 1 Newton displaces a body through 1 meter, when a force of 1 Newton displaces a body through 1 meter, the work done is 1 Newton meter. Okay, now if I apply a force of 1 Newton and I can displace the object through the 1 meter. Okay, I am not interested about the mass of the object. I am not interested about the mass of the object. I am just applying a force of 1 Newton and I have displaced the body through the 1 meter. The work is done, said to be done, that is 1 Newton into meter. Now this 1 Newton into meter is briefly known as joule. This 1 Newton into meter is briefly known as joule. So what is 1 joule? 1 joule equals to 1 Newton into meter. Now in the CGS system, okay, in CGS system, the 1 joule is equals to 10 to the power 7 arc. In the CGS system, the unit of work is arc. How the arc comes? Let us see how the arc comes. Okay, first, what is the concept of 1 Newton? Okay, what is the relation between the Newton and what is the relation between the meter and centimeter? Okay, first we have to know this point. Now, what is 1 joule? What is 1 joule? 1 joule equals to 10 to the power 5. Okay, 1 Newton. Let us move this one first. 1 Newton is equals to 10 to the power 5. Ten to the power 5 dyne. Okay, 10 to the power 5 dyne. Now 1 Newton in 10 to the power 1 Newton equals 10 to the power 5 dyne. Now 1 Newton meter, that means 10 to the power 5 dyne multiplied by 1 meter equals to 10 square centimeter. 1 meter equals to 10 square centimeter. So it will be 10 to the power 7. 10 to the power 7 arc. This is called arc. And arc is a unit in the CGS system. Now in the FPS system, it will be called as a 1 foot into 1 pound. Okay, this is 1 foot poundal. Now what is the relation between the 1 foot poundal and arc? That is 1 foot poundal equals to 4.214 into 10 to the power 5 arc. 1 foot poundal equals to 4.214 into 10 to the power 5 arc. Okay, now how this relation derived? You can see 1 foot. Okay, 1 foot is equals to how much centimeter? That is 30.48 centimeter, around 30.5 centimeter. Okay, and 1 poundal, that is equals to 13,825 13,825. Okay, 13,825 dyne. So 13,825 dyne into 10 to the power into 30.5 centimeter. So if I multiply it, it becomes 4.214 into 10 to the power 5 arc. Okay, so I have clearly relation between the SI system, CGS system and FPS system. In the next, I have written 1 kilonewton meter. Okay, kilonewton meter, that means 1000 newton meter. Okay, or 1 kilojoule. 1 kilojoule same as the 1 kilonewton meter, and 1 kilojoule equals to 1 kilonewton meter. Okay, so these are the relation are very important for the railway CBT2 exam. After we have completed all our session, okay, first we will derive some problem. Okay, we will work out some problems, some basic problems, fundamental problems, and at the end of all our session we will discuss some of the important MCQs for this general engineering sections. Okay, for your CBT2 preparation. Okay, moving to our next slide. In the next slide we have written the dimension of work done. The work done, what is work done? Work done equals to force into displacement. Work done equals to force into displacement. And what is the dimension of force? For dimension of force should be remembered, and it is ml to the power minus 2. Now what is the unit of the displacement? Displacement equals to ml to the power minus 2 multiplied by L. So the work done will be ml square to the power minus 2. Okay, so this is very simple and you have to remember all this thing for your exam. So next, now let us take some example to complete our session. Okay, what is the first example? First example says that if 150 joule work is done, okay, 150 joule work is done to displace a body of 50 meter, of body to 50 meter. Now I have given two information are given to me. What are the information? The information is work done. What is the work done? Work done is 150 joule. Now what is the force? What is the force exerted? I don't know. So F, and what is the S? S is 50. Now what will be the F? F will be, if I eliminate this one, F will be 3. F will be 3 Newton. Of course Newton. Why Newton? Because this is SI system, this is also in the SI system, meter. Okay, joule per meter, that is Newton. Okay, so a very simple thing, 150 joule work, so W equals to 150. What is force? This is unknown. And what is the displacement? That is 50. Now F equals to 3 Newton. A very simple problem for RRB CBT2, not for the JE and SE. Okay, in our future classes we will of course bring the JE and SE classes in our channel. Next, now if a mass of 10 kg is lifted by 5 meter, what is the work done? Okay, so if a mass of 10 kg is lifted by 5 meter, now if the mass is 10 kg, what is the force? Force is G. Okay, force equals to mass into G. So mass equals to 10 kg and G is 9.8. Okay, G is 9.8. So if I multiply this one, it will be 98. Okay, 98 Newton. Now what is the work done? Force into displacement. What is the work done? Force into displacement. What is the force? Force is 98. Force is 98. And what is the displacement? Displacement is the 5. Okay, felt 98 multiplied by 5. Okay, how much it will be? 2 is less than 100, so 490 the answer. 490 joule will be the answer. Okay, so very simple problems will be asked in CBT 2 exam. These questions are also very important for the RRB JE and RRB AC. Okay, so next, okay, moving to some typical problems that can be asked. Okay, I'm not definite about that. What is the question said? Question said a horse pulling a cart exert a steady horizontal pull of 200 Newton, okay, and walks at the rate of 4.5 kilometer per hour. How much work is done by the horse in 5 minutes? Now what is 4.5? I'm talking about the 4.5 first. 4.5 kilometer per hour, okay, and here we are interested meter per minute. Okay, 4.5 kilometer per hour, that is equals to 75 meter per minute. How they came? 4.5 kilometer per hour, okay, kilometer per hour, okay, by hour. Now 1 kilometer means 4.5 into 1000 meter, and 1 hour means 60. Okay, so if I eliminate, that means 450 divided by 60, and 450 divided by 60 will be 75 meter per minute. Meter per minute. Let me remove some of them. Okay. Okay, so what I have done, I have converted the kilometer per hour to meter per minute, because in the question I have been asked that how much work is done by the horse in 5 minutes. Okay, so I am interested in minute, so I have done convert the 4.5 kilometer per hour to meter per minute. Already I have calculated that the 4.5 kilometer per hour equals to 75 meter per minute. Now this is the distance per minute. Okay, now what is work? Work done is equals to force. What is the force, amount of force? Force is 200 Newton. Force is 200 Newton multiplied by, this is the meter per minute. Okay, per minute 75 meter. Now how many minutes? 5 minutes. So I have divided again by the 5. Okay, I have again divided by the 5. So 75 into 2, 300. 75 into 2, 300. Now this 2 into 5. 3 into 5, 15. Okay, now 1 2 3 4, 1 2 3 4. Now so 150 kilojoule, 150 kilojoule. Okay, 150 kilojoule will be the correct answer. Okay, moving to our next problem. Here a very typical question, a very good question. A trolley of mass 200 kg moves on a level track for a distance of 500 meter. If the resistance of the track is 100 Newton, find the work done in moving the trolley. What is work done? What is the work done? Work done equals to force into distance. Work done equals to force into distance. Now what is the force? Force is 100 Newton. Force is 100 Newton. And what is the distance? Distance is the 500 meter. Distance is the 500 meter. Okay, now why I am not interested about this 200 kg? Because I have in the time of definition in the previous video, I said that I am not interested in the mass of the body. Okay, what I am doing, I am just applying a force. That's applying a force is acting against the resistance of the track. Whatever the force I have applied, that is acting against the resistance of the track. The resistance of the track is 100 Newton, and now the force 100 Newton multiplied by distance. What is the distance? Distance is the 500. So if I multiply the 500 into 100, that means 50,000 joule. That means 50 kilojoule. What is the correct answer? 50 kilojoule. I hope all the 4 problems are the very basic problem and very important for RRB CBT 2 and also for the RRB JE and the RRB AC. Now let us move to some other theories of this section. Okay, there are other theories, a concept of positive work done. Okay, what is a positive work done? When the work done is against a force, it is known as the positive work done. And when the work done is by a force, then it is called a negative work done. Okay, what is the example? Let us take some example so we can easily understand. Now if I now from a rooftop, if I throw a ball in the upward, okay, what is happening? The acceleration due to the gravity is working downwards, and my force is working the helping the ball to move the upwards. Okay, now what I am doing, my work done is against the acceleration due to the gravity, so it is a positive work done. And now from the rooftop, just I throw the ball downward. Okay, from the rooftop I just throw the ball downward. Okay, if I throw the ball downward, that means the acceleration due to the gravity, the work is done in the acceleration due to the gravity. Okay, so the work done by the force, by me, that will be the negative work done. Okay, but by the acceleration due to the gravity is a positive work done. Okay, when I'm throwing up the ball, okay, I'm just repeating once again, this is a very good concept of physics. If I throwing up the ball to the upper section, okay, what will happen? I have applied a force on the ball, okay, that is working against the gravity, and so that is a positive, and the acceleration due to the gravity are negative. But when I throw the ball downward, the acceleration of the gravity is a positive work, but my work done, okay, I have applied a force, that will be a negative work done, because the work done by a force, okay, and when I am throwing to the upper section, there is a work done against a force. Whenever the work done will be against a force, then will be a positive work done. Okay, next, concept of zero work done. Okay, there are the very two simple examples of zero work done. One is moving a suitcase in the hand. Okay, this example can be asked in your question in the railway exam. What is moving a suitcase in the hand and the centripetal force? Now let us take the example. Now this is a road, and suppose okay, so you are moving to a road and displaced to a distance of s, okay, and finally you came to this point. Okay, you have a suitcase in your hand, or you have a bag in your hand. Now you can clearly see that if the direction of motion, what is the direction of your motion? The direction of motion is along this direction. Okay, this direction. Okay, this should be parallel to this one, and the work done, okay, see, this is against gravity always. Okay, and what is done by your hand? Your hand is pulling the bag from not letting it into the earth. Okay, so they are perpendicular to each other. Okay, this is the displacement and this is the force. Okay, and they are perpendicular to each other, and when they are perpendicular to each other, the work done will be zero, though you are moving the bag from one point to another point, but the work done, the total work done by you, will be zero. This is a very simple example. Again, there is another example of the zero work done. What is the another example? Now this is a circle, okay, circular motion. Now if a body is moving, okay, his body is moving along the circular direction, what will happen? There will be a force acting to the center, and we call the force is as a centripetal force. This force is known as centripetal force. Okay, next, what we can say, that the motion of the body is always along the tangent. Okay, if the motion of the body is always along the tangent, okay, and this is this is the direction. Okay, the direction of the centripetal force is towards the center. Now they are always 90 degree to each other, so at that condition the work done is also 0. Okay, these two examples can be asked in the RRB CBT too. So hope for the best, and we have completed our first session. Okay, hope you have liked the session. If you have liked the session, please share our video, and if you are watching our video and you haven't subscribed to our channel, please subscribe to our channel, and press the bell icon too, okay, for the next classes, and wait for the next class. Thank you.